Welcome to massive open online course on basic principles and calculations in chemical engineering. So, in this course we have 12 modules and around 36 lectures, and we will cover all the basic principles and calculations in chemical engineering successively. Today we will discuss in module 1 as an introduction, where some definition, history and role of chemical engineers will be discussed in this lecture. So, it will include the definition of chemical engineering, history of chemical engineering and role of chemical engineers in the society. Now, as we know that various aspects of chemical engineering which actually leads to for the welfare of human being based on the industrial focus with some mechanical design of equipment for the process of production of essential chemicals, which are very important for our daily lives. So, for that the knowledge of applied sciences that employs physical, chemical and biochemical rate processes for the design of equipment and plant. So, if we say about the floor of chemical engineering, we have to think about based on which that engineering aspect for the welfare of the human being is required. So, initially we have actually focused on that what should be the actually basic history of that chemical engineering, from where this chemical engineering profession started, and what are those main aspects of chemical processes and also how that chemical engineering processes developed for the production of essential chemicals in society which are required for our daily life. So, in that case before going to that we have to say that this engineering, whether it is chemical engineering or mechanical engineering or civil engineering, all those engineering streams that actually basically depends on that some sciences, theory of sciences, and then that science has to be applied for the production of essential chemicals there. So, you have to apply that sciences, how to develop the process based on that sciences, like that to produce, suppose that some sodium hydroxide solution, calcium hydroxide, even chlorobenzene, some organic chemicals, LPG, even like that petrochemical industry, there are several oils those are produced, that is of course coming based on some processes. So, all those processes whenever being done, that processes of course will be based on some fundamentals of the knowledge on sciences. That sciences may be physics, maybe chemistry, maybe bioscience, even mathematics also. So, those sciences will be required to develop that the equipment and also that plant accessories to to procure that plant to produce that particular chemicals based on a certain process. So, anywhere if any process is developed, that will be depending on the applied sciences. So, that applied sciences converted to the chemical engineering based on that knowledge of physics, chemistry, bioscience and mathematics, etc. So, here one schematic diagram of that process is shown, that is basically in the laboratory scale some processes developed based on that sciences like physics, chemistry, bioscience and mathematics, and from those sciences if you are applying in laboratory scale and what should be the product, then that process will be scale up in industrial scale, and that scaling up that processes and converting these processes as represented by that chemical engineering that will be that called that aspect of chemical engineering and related to that applied sciences. Now, before going to the discussion on this chemical engineering process and also different aspects of chemical engineering and its basic calculations and also that principles of that chemical engineering process, you have to know that what is the definition of that chemical engineering. Actually, there was no universally accepted explanation of the field of chemical engineering at its start, and there are some processes developed at early stages, basically in 19th century. There whenever a process was developed, that processes were actually based on that some engineering aspect, based on some science knowledge, and also for that some preamble of that consortium to make this chemical engineering profession. And based on that preamble, the chemical engineering actually was defined as that chemical engineering is the area of applied science that puts to use that physical, chemical, biochemical rate processes to produce essential chemicals and articles for the betterment of human uses. So, this was the first definition of this chemical engineering, which were actually made based on this preamble of chemical engineering aspects at the 19th century. And as per dictionary, the chemical engineering is defined as it is a branch of engineering which involves the design and operation of large scale chemical plants, petrochemicals, refineries and the like others. So, this is the definition of chemical engineering as per dictionary of chemical engineering. Even other definition of the chemical engineering given by different organization, like in that case as per information highway, the global information and communication networks. So, based on their aspects, their view, the chemical engineering is defined as it is actually concerned with the process that cause substances to undergo required changes in their chemical or physical composition, structure, energy content or physical state there. So, this is the definition given by information highway. And later on, a more appropriate definition of chemical engineering as per constitution of American Institute of Chemical Engineers, and the organization states this definition of the chemical engineering as the branch of engineering which deals with the application of principles of the physical sciences together with the principles of economics and human relations to field that pertain directly to processes and process equipment in which matter is treated to effect a change in state, energy content and also composition. And so, these are the different definitions of the chemical engineering given by different organization, and based on which we can say that basically this chemical engineering which is developed based on the knowledge of applied sciences. So, all sciences will be contributing to the development of the chemical engineering. So, that is why this chemical engineering nowadays is that interdisciplinary professions in which all the streams of sciences are contributing a lot for their basic sciences to the application state to the chemical engineering processes. And what is that chemicals actually? You have to also understand the meaning of that chemical. This is basically represented by a substance which involves or results from a reaction between two or more substances, or you can say that will relate to the substances that something consists of. So, in this way you have to define that chemical, what is that chemical means for the aspect of chemical engineering, from where you can say that based on this that chemical, how it can be processed. So, that processing is actually represented by that engineering aspect, and that engineering will be based on that that science of all streams. Now, if we look back to the starting of the chemical engineering, so in 18th century, at the last that part of that 18th century, especially in 1888, you will see that for all intents and purposes, the chemical engineering profession actually it began in 1888, and the term in that case chemical engineer had been floating around technical circles throughout the 1880s, but there was no formal education for such chemical engineering profession to given to a particular person recognition at that time. So, this is actually beginning of this chemical engineering. However, the chemical engineer at this stage that was either a mechanical engineer who had gained some knowledge of chemical process equipment, and also the chemical plant sometimes required some that observer, or you can say foreman. So, at that time a chemical plant foreman with a lifetime of experience but little education actually regarded as a chemical engineer, and at that time it was said that an applied chemist who can be actually regarded as a chemical engineer if he has some knowledge of large scale industrial chemical reactions. So, basically the chemical engineering was not actually defined properly at that time. If anybody works on that chemical plants with some special knowledge of some chemical reactions, or some that knowledge of chemical process equipment, they were actually regarded as that chemical engineer there. But in 1880 George Davis, so at that period he actually just made a group of those foremen or some persons, those who knows that chemical process equipment design as well as the reactions. They are actually made together as a society of chemical engineers, but anyway this making of this chemical engineering society were not actually successful at that period. However, this that model state of that affairs to make this society of chemical engineers was changed in 1888 when this professor Lewis Norton of the MIT USA that introduced course 10, thereby that uniting chemical engineers through a formal degree. And at that time some other organization also was thinking how to make that one professions of this chemical engineering by giving some that coursework to that to those peoples, and also some new peoples, or giving the training of that chemical process equipment design as well as that reactions. So, they have started their formal degree on this chemical engineering. So, in that case University of Pennsylvania and Tulane University quickly followed suit, adding their own 4-year chemical engineering programs in 1892 and 1894 respectively. just after that 1888, when this Professor Lewis Norton made a a course 10 for the chemical engineering degree by giving those course training there. And after that there are several persons they got their chemical engineering degree from different organization, and they actually become renowned chemical engineer based on their work experience, as well as their development of some other equipment which will be directly or indirectly related to the chemical engineering process. So, in that case we have to salute them, that historical chemical engineers who has developed chemical engineering based on the science of different streams, and they have that regarded it as a science of chemical engineering. So, those historical chemical engineers have contributed a lot initially to develop these chemical engineering professions. In this case John Dalton, he is one of the pioneer chemical engineers at that time, and he published atomic weights in their research articles when he was working with this development of science of chemical engineering. And he actually worked on that atomic weights, how these atomic weights will allow the chemical equations which is to be balanced, and also how it can be established the basis of chemical engineering mass balances. That was done in 1805, and he was at that time the fellow of Royal Society, and he was that English chemist, physicist. I mean he was called as meteorologist in 1805. So, he was the first that that persons who has developed the chemical equations, how to balance it, and also how to do the mass balance for that chemical engineering processes. After that 1824, French physicist Sadi Carnot, and he also worked on that it is called combustion reactions, and what is the thermodynamic aspects of combustion reactions, energy in, energy out, and what should be the different characteristics of the thermodynamic properties on that combustion reactions. He in 1824 he has actually written a book to study the thermodynamics of combustion reactions, and he described the Carnot cycle in his books, how to relate to the theory of heat engines. He also described in his books, and he actually published that books. What was the name was that Reflections on the Motive Power of Fire. So, that was the first book to study the thermodynamics of combustion reactions. And after that 1850, that R.J.E. Clausius, he began to apply the principles that is developed by Carnot to chemical systems at the atomic to molecular scale. So, this was one of the important milestone of at that 19th century where this chemical engineering processes actually based on the development of the chemical systems based on that converting from the atomic to the molecular scale. After that around 10 years, that is 1873 to 1876, during that period at Yale University, the American scientist, he is called is Josiah Willard Gibbs. He made significant theoretical contributions for the study of chemical systems, which is used to calculate the thermodynamic characteristics and also it is called that thermodynamics of Clausius. So, this is one of the important period where this chemical engineering contribution to that thermodynamic analysis was significant, even remarkable. After that 1882 Helmholtz he published a founding thermodynamics paper similar to Gibbs, and he also showed that the measure of chemical affinity, that is force of chemical reactions, how that chemical reactions is happened, and based on what is the driving force for that chemical reactions, and he gave that theory to determine and also by measuring the free energy of the reaction processes. So, he actually gave that theory of force of chemical reactions, which is determined by the measure of the free energy of the reaction process. After that 1880 this called Davis, that is George C. Davis, he proposed the unsuccessful formation of the Society of Chemical Engineers in London, that I have already discussed, that it was not successful just to make that Society of the Chemical Engineers based on that person, those who are working in the chemical industry and who has some knowledge on that chemical processes. Later on because of this unsuccessful formation of this Society of Chemical Engineers in London, in 1887 he presented a series of 12 lectures on the operation of chemical processes. Now it is called unit operations, that is one of the main important subjects in chemical engineering, and he actually presented this series of 12 lecture on this operation of chemical processes as a unit operation at the MIT school, technical school. And in 1901 he also published a first book in chemical engineering, that is called Handbook of Chemical Engineering. There he described a lot of that theories, even development and history of the chemical engineering, and what are the different aspects for the professions of the chemical engineering. He described in his first book of chemical engineering, and how this science can be applied and it can be processed for the betterment of the human life just by developing different essential chemicals. He has given some theory on that. So, it was one of the important books in chemical engineering history. And after that in 1883 that was born Reynolds. He is also one of the renowned person in chemical engineering who has contributed a lot in that fluid flow operation, based on which that all chemical engineering processes are assessed. And he defined the dimensionless groups for fluid flow, and that dimensionless group for the fluid flow leading to the practical scale up and also understanding of the flow behavior, heat transfer behavior, even mass transfer characteristics in the chemical engineering processes. Those who are nowadays still it is hardcore subject in chemical engineering education as well as in industry for their design of equipment and even other process development. And in 1885 that Henry Edward Armstrong he offers a course in chemical engineering at Central College. Nowadays it is called that college name is changed, it is called Imperial College, London, and he was active in scientific research, and he was actually working on the subject of chemistry of naphthalene derivatives, how to naphthalene can be produced from that from the root crude oil, as well as some derivatives, how it can be produced from the naphthalene. So he has given that theory on that chemistry of naphthalene derivations from the root chemical root that crude oils there. He was also a fellow of Royal Society of Edinburgh, and he is basically English chemist. So, from that chemical knowledge of that conversion or chemistry of that naphthalene derivatives, from then onward there are several synthesis of the chemicals that was done based on the idea that is opened by that Henry E. Armstrong in 1885. And later on 1888, that is professor of organic and industrial chemistry at MIT, he started a new curriculum at MIT as a course 10 as a chemical engineering. From that basic degree of chemical engineering started based on this course 10. And then based on this course structure, he made first that chemical engineer, you can say that formal chemical engineer, world's first formal chemical engineer was William Page Bryant and his classmates. So, in 1891 MIT awards a Bachelors of Science in Chemical Engineering to William Page Bryant and 6 other classmates of that William Page Bryant, and then onward actually they were actually recognized the world first chemical engineers group from MIT. So, in that case William Page Bryant was the first of 7 students to graduate from course 10 and thereby become the world's first formal chemical engineer, and he is known as like that. After that in 20th century, at the very beginning of 20th century, Oliver Peterson Watts, the University of Wisconsin actually awarded the first PhD degree to him in chemical engineering, and he was a professor of chemical engineering and applied electrochemistry at the University of Wisconsin Madison until 1937. And he is famously known for his development of the hot nickel plating bath, and it is known as that Watts bath. After that this Hilda Derrick, he was also chemical engineer, and she was the first female student member of the Institute of Chemical Engineers. So, these chemical engineers are the renowned chemical engineers who has got that basic degree in science of chemical engineering, and they were actually the building pillars of these chemical engineers, and they were renowned historical chemical engineers there. And from then onward, this 1945 onward, that is in 20th century, there are several works, there are several scientists, they are working in chemical engineering, there are several research were actually done on this chemical engineering development of the chemical engineering professions, and based on this nowadays that society are being developed based on this chemical engineering processes in different ways. Now, if we actually look back on that the milestone of that chemical engineering professions at the 20th century, we will see that several aspects of chemical engineering development, and from then onward we will see that this chemical engineering began as a distinct profession at the start of the 20th century. Although elements of what are now considered to be core chemical engineering have existed for centuries and more, and also you can say that it begins as a something of an amalgam combining chemistry, having an industrial focus with the mechanical design of equipment. But you can see that this the beginning of that chemical engineering, you can also say that fermentation is also developed process at that century of that beginning. So, this fermentation, not only that period, but it was also earlier stage in Bibles also it is mentioned that this fermentation process, and also in Homer also it is mentioned that fermentation process. So, this discipline began as something of that this fermentation process and also other some chemical engineering processes based on that knowledge of chemistry, which have some industrial focuses with the mechanical design of equipment. And if we say that early triumphs which defined the profession in the public eye had to do with the large scale production of that essential chemicals based on this chemistry of this amalgam, even fermentation process, even other processes based on the knowledge of those things, and also idea development, also concept of those basic things, and later on also now the knowledge has been actually opened up for the development of further process based on the chemical engineering aspects. Now, if we talk about that 1915, it was regarded as milestone 1. So, in that case fermentation processes have existed throughout human history, and the first industrial scale fermentation process other than alcoholic beverages for the production of acetone and butanol through the anaerobic fermentation of corn by the organism that is called Clostridium acetobutylicium that is discovered in 1915 by the British chemist that is came with men. And the production of that acetone by this route was actually essential to that British war effort in First World War, because that acetone was required as a solvent of nitrocellulose in the production of smokeless powder. So, in that case calcium acetate from which acetone was normally produced based on this fermentation processes. So, this is regarded as milestone 1 of this chemical engineering process. Whereas later on this 1930 the early triumphs which defined the profession in the public eye had to do with the large scale production of essential chemicals and the invention of the fluid catalytic cracking in fluidized bed. In the chemical engineering aspects, we can say that process developed by Warren K. Lewis and Edward R. Gilliland in late 1930s. In that case it was one of chemical engineering advanced process development, and that process is very energetic and also you can say that it will be economic and also efficient. Its invention was crucial to the production of high octane aviation gasoline during Second World War, and also it was actually the heart of that centerpiece of the modern petroleum refinery. Still it is centerpiece of the modern petroleum refinery. And so, this is actually this invention is regarded as the milestone 2, and that was actually discovered in 1930. After 10 years in 1940, as we say that it was one of the important milestone, and in this case the development of the large scale aerobic fermentation process for the production of penicillin in early 1940s. It was required because it is one of the outstanding engineering achievements of the century, where that production of chemicals by the biological routes that remains a core part of the biochemical engineering, and which has always been an essential component of the chemical engineering there. After that 1942 to 1945, you can say that it is the war period. Of course, that war is unfortunately a recurring theme in identifying the great chemical engineering advances in the 20th century. At that period, the Japanese conquest of the rubber plantation of Southeast Asia of the start of World Second War necessitated the industrial development of the synthetic rubber. And in 1942, a US government sponsored an industrial academic consortium, and also there this set out was required to produce large amounts of synthesis rubber. It is called GRS rubber, which is that mixture of 75% butadiene and 25% styrene. And by 1945, the United States was then producing around 1 million tons of synthetic rubber annually. Then 1945 onward, you can say that chemical engineers continued to play a central role in manufacture and processing of polymeric materials, and chemical engineer of the first half of that 20th century was generally concerned with the large scale production of chemicals. Usually you can that say thorough classical chemical synthesis, and also you can say that the beginning of that profession of chemical engineering expanded considerably in outlook during the second half of the century. So, from then onward, this chemical engineering progress continued to till date, and from then onward, that is 1945 onward, from that latter half of this 20th century, several chemical engineers they were working, even nowadays also renowned chemical engineers they are working in different process development based on the chemical engineering science knowledge. In that case they were actually facing a lot of challenges for the development of the process based on this chemical engineering knowledges, and different challenges like that how to make that solar energy economical, how to provide energy from fusion, how to provide access to clean water, even reverse engineer the brain, even you can say that advanced personalized learning, developed carbon sequestration method, even how to develop a tools for scientific discovery, even restoring and improving the urban infrastructure, how to do that, advance in how health informatics, how to prevent nuclear terror, even you can say that how to engineer better medicines, how to enhance the virtual reality, how to manage the nitrogen cycle, how to secure cyberspace. So, all those engineering challenges are coming from then onward for the betterment of our human life. So, for those challenges are facing by different engineers from different streams, but in that case that most of this part of this challenges are taken by that participation, that is called active participation and leadership of chemical engineers. Now, then what should be the role of that chemical engineer today based on those engineering challenges. So, chemical engineers play important roles today in every industry, and you can say service profession in which chemistry or biology, where those are a factor, those are factors including you can say that semiconductors, nanotechnology, food processing, agriculture, environmental control, pharmaceuticals, energy, even personal care products, finance, medicine, and of course, you can say traditional chemical and petrochemicals. So, all those challenges are taken by chemical engineers for the better and better way to give essential chemicals as well as some other services to the human development and also growth of our society in better way. So, chemical engineers have traditionally been involved in both the design of process and design of products under those challenges. Now, if we talk about that role in semiconductor production, how that chemical engineers actually that role on this particular semiconductor production. Let us look back on those parts as a modern chemical engineer, how they are doing this production of semiconductor, how that chemical engineers are actually important on this particular production, semiconductor production. So, in this case this production of semiconductors is actually driven by the chemical engineers who have derived many of these processes for the manufacture of computer chips, which are dependent on chemical and rate processes. In this case Andrew Grove, a chemical engineer who has one of the three founders of the Intel corporation and its CEO for many years. So, he was actually basically chemical engineer, still he was working for the development of the semiconductors based on their that some idea which is developed based on the basic sciences, and as a chemical engineer he has contributed a lot for the idea for the development of this semiconductor production. And nowadays chemical engineers also are working in controlled drug release. In this case Alan Michaels, he is one of the that pioneer chemical engineers, where he contributed a lot as a chemical engineer in this controlled drug release, where polymer gels is one of the important material that release a drug over time, and the issues related to the release like the solubility of the drug in the gel and the uniformity of the rate of release, and also biocompatibility for many materials that is placed in the body. Now, these aspects or these factors, how actually effects on this polymer gel production stage, and in that case this Alan Michaels, he has given some idea, even he developed this basic fundamentals of this polymer gels production to control that drug release, and in this case he was one of the leaders in developing this field, but he was a chemical engineer and who was the president of also Alja Research in 1970s there. So, that is why these chemical engineers can work in different way out of these chemical processes, but he can work on that some other process development, like in biochemical process, like in computer chips production, semiconductor production, all those things. Even synthetic biology, in that field also chemical engineers play important role. Like synthetic biology that employs the new access to the genetic code and that synthetic DNA to create novel chemical building blocks by changing the metabolic pathways in cells, which then function as microchemical reactors. So, one of the leading figures in this new field is chemical engineer Joe Kissling. He constructed a practical and inexpensive synthetic biology route to artemisinin, which is actually the medication of source for combating malaria, that is resistance to quinine and its derivatives. So, this is one of the important that field where these chemical engineers can give some idea for the synthesis of chemicals for this that I think that synthetic biology field. And also chemical engineers play important role in environmental control. In this case chemical engineers control the environment both through the development of green processes and improved methods of dealing with air and water quality. In this regard chemical engineer John Sinfield and his colleagues that developed the first mathematical models of air pollution in 1972, and they are also leaders in the development of urban and regional models of atmospheric pollution, especially the processes that form ozone and aerosols. Later on David Boger, a chemical engineer, managed the disposing of bauxite residue wastes from the aluminum manufacturing process, which are in the form of a caustic colloidal suspension, which is called red mud, and huge red mud actually were produced at that this processing of that caustic soda, even some other that bauxite field there. Whenever deposing of bauxite residue wastes from the aluminum manufacturing processes. So, he has actually managed this colloidal suspension, that is called red mud, just by converting this red mud to valuable products. So, he used the suspension to make valuable materials for the treatment of wastewater for reuse and reducing the volume of waste by a factor of 2. Chemical engineering also work in nanotechnology, like you can say that scientific interest was grown actually to the exploitation of chemical processes with the length of scales of the order of 100 nanometers or less since the early 1990s. So, from then onward you will see that there will be huge change of process development from this macro to the nano scale range to better process yield, to get the intensification of the process based on this nano scale processes. And thinking of that nano scale processes, chemical engineers they have actually did lot of research on this nano technology based chemical process development, process intensification, just by based on the different physical and chemical properties from the molar quantities of the same material. In that case, catalytic properties of the material and in interfacial phenomena between unlike materials are nowadays is determined at this nanoscale for the intensification of the process in chemical engineering. Now, nanotechnology holds great promise in the development of chemical sensors also. If a sensor element is reduced in size to molecular dimensions, it becomes possible to detect even a single analyte molecule by the sensor. So, this sensor development based on this that molecular properties and in the nanoscale range, and how this nanoscale range properties of the molecules can be utilized to development of these sensors by this analyte molecule. It is actually being developed by this chemical engineers also. Chemical engineer Michael Strano used carbon nanotubes to create nano channel based sensor to detect very low levels of impurities such as arsenic in drinking water. So, his contribution is one of the important development in this nanotechnology based chemical processes. And chemical engineer Matteo Pasquali and his colleagues, they are also chemical engineer, discovered a process or way you can say to process carbon nanotubes to produce high strength fibers that are electrically conductive for the application of reduction of the weight of aeroplane panels as lightweight electrical conductors for data transmission and for long distance power delivery. So, these chemical engineers they are also working, and even they have developed nano tube based high strength fibers for the design of aeroplane for its reduction of the weight. Chemical engineer David Swain, he is also one of the renowned chemical engineer who has invented and commercialized the nanocar processes in which cotton fibers are wet with an aqueous suspension of carbon nano whiskers that are between 1 and 10 nanometer in length. It generally causes liquids to breed up instead of spreading there. And chemical engineers also play a significant role to derive the synthetic polymer industry, development of new materials and their processing to make useful objects for the society. In this case, Core TX film, which was invented by chemical engineer Robert Gore, and it is actually a porous film that made from polytetrafluoroethylene, or you can say it is in short it is called PTFE, and is commonly known by trade name Teflon, and this film is widely used in outdoor wear, but it also has found medical application as synthetic blood vessel. So, in this case Robert Gore's contribution as a chemical engineer is that remarkable. The chemical engineers Frank Betts and Glenn Fredrickson, those are also contributed a lot for the production or development of a new transport plastic polycyclohexyl ethylene. These are generally used in optical storage media to convert a brittle glassy material into a tough thermoplastic which is suitable for disc manufacture. Now, in colloidal science, which is one of the hardcore process of chemical engineering, in that case we have to remember this Elias Gust, who actually was the forefront of the development and exploitation of colloidal science in a wide range of applications. He discovered this rheology, and this is a phenomena of the viscosity of a suspension of colloidal particles that contains permanent you can say dipoles, that is increases by orders of magnitude upon application of an electric field. And the process application to devices such as classes are one of the important you can say that application where colloidal science is knowledge is required, and in that case the theory for this viscosity change of the suspension of colloidal particles which contains that permanent dipoles, and also how it can be applied to the application for the development of device for the classes. So, in this case Alice Gast is that is one of the important scientist in chemical engineering background. Also significant role in tissue engineering are given by these chemical engineers. In this case Christy S. Anseth, who is a professor of chemical engineering in Harvard Hazes Medical Institute, who has developed an injectable and biodegradable scaffold to support Kurtz's cells as they grow to regenerate diseased or damaged cartilaginous tissue, where they have actually developed the process how this tissue can be engineered for the replacement of the organ for its respective functions, typically by constructing biocompatible scaffolding on which cells can grow and differentiate. In the treatment of water, one of the important chemical engineering process where chemical engineers play an important role for the water desalination. That membrane based separation is one of the important process in chemical engineers, where you can say this membrane is being used in a variety of applications for this water treatment, characteristics like hemodialysis, even oxygen enrichment, development of reverse osmosis process for the water desalination. In this regard, these chemical engineers Sidney Loeb and Srinivasa Shauri Rajan are famous for their development of reverse osmosis process, which was actually developed in 1959. So, this process is still important for the water desalination process for our drinking water system. Now, how that chemical engineers works in alternative energy sources. Now, chemical engineers works in the development of alternative energy sources away from that traditional fossil fuel. In this case, solar energy for electricity production is one area in which the chemical engineering role is remarkable, we can say. So, in this regard we have to remember T.W. Fraser Russell, which is a leader to motivate a research and development team for the continuous production of solar cells, and also he designed a reactor that deposited the semiconductor continuously on a removing or you can say moving substrate. So, in this case his name is of course as a chemical engineer is remarkable. And also you can say that role in quantitative bioscience, in this case chemical engineers are playing an increasingly important role in modern biology and biomedicine. So, chemical engineers play a important role in alternative energy sources also. So, in that case chemical engineers works in the development of alternative energy source away from the traditional fossil fuel. So, in this regard Fraser Russell is a leader to motivate a research and development team for the continuous production of solar cells. So, in this regard he is one of the pioneer chemical engineers for the development of alternative energy sources. Other than these chemical engineers also play a significant role in quantitative bioscience research. In this case Rakesh Jain whose contribution in the entire education in chemical engineering developed the network of blood vessels and transvascular transport in tumors. And it is of course remarkable to say that Dr. A.K. Chakraborty is a chemical engineer who uses a statistical and quantum mechanics to study molecular conformation. He gave the first quantitative and testable explanation of the immune systems which is a recognition process and illuminated process which give how actually some humans can control the HIV virus. So, other than this chemical process development even role in chemical biochemical processes even in other engineering field chemical engineers can play an important role in public services also, like chemical engineers can act as an administrator of Environmental Protection Agency. He can be a secretary of energy sector, he can provide expert advice to the government for the research and development in science and engineering. He can act as an evaluator of processes for destroying stores of armed weapons loaded with different agents, and other professions also he can act, like to study the medicine, even to study law, especially patent law, to enter the financial sector which has been a large employer. So, in this case these chemical engineers can give a better contribution also in different other professions. In this case you have to remember some renowned persons who were chemical engineers, but they have contributed lot in other professions, like Adam Osborne. He also developed the first commercial portable computer in 1981. Chemical engineering background, the physicist and Nobel laureate Yusinra Wigner, called father of the nuclear engineering. He has contributed a lot for the uranium separation process. He was in fact a chemical engineer by education at his all degree levels. And the physicist Edward Taylor, he is known one of the renowned person as the father of hydrogen bomb, and he also studied the chemical engineering for his first university degree. So, this chemical engineers works not only in the chemical engineering professions, he can act, he can give a contribution to the other professions also. So, we have discussed several aspects of that chemical engineering development history and the role of chemical engineers in the process development and also history of chemical engineering development, and also aspects of different other professions how chemical engineer can act. So, thank you for your attention for giving this this lecture. I would suggest you to go for further reading, and I have given some textbooks, reference books here, and Next lecture will be on basic features of chemical process. So, please follow those lectures for the basic principles and also what are the basic features of chemical process, that will be given in the next lecture. So, thank you.